Okay, this is the last question, the analytical geometry questions of 2020, paper two. So here we go. They tell us a story. They say in this diagram there's S, W, R, L, L, but there is no L on the paper. But they go in that order and it forms a parallelogram. Well, that's your first job. Go from S to W to R in the picture. Now, the only way to make a parallelogram going in that order is to go down here to L. Now, it's going to help you if you have a picture like this. So that's your first step to make a picture like this. Now it says calculate the area of this. Calculate the area of this. Well, there's some things that you've already got. You've got that R. You kind of know what R is. Um, that's given from another question. You know that the length WR from question 3.4 is 72.5 units. You also know that S is negative 20 and negative 4. Hey, you've got a lot of coordinates here to work with. In fact, you've got the coordinates, you've even got this length. This is a parallelogram. This is the base of the parallelogram. Wow, if we could figure out the height of this parallelogram, the formula for the area of a parallelogram is base times height. We'll have our answer. That's all we have to do. Well, the height would be the perpendicular distance from this base, there's a base, perpendicular distance to S. Well, that shouldn't be so hard because where are we here? We're at minus 20, and then over here, we've gone to minus 4. We just have to figure out what is that distance? What is the distance from minus 20 to minus 4? Well, that's pretty easy. You just go minus 4 minus minus 20. I think you get 16. Well, now you know what? You've got the whole thing figured out now. You could work it out with two different triangles and do it like, because it's like a triangle here and then an identical triangle here. But I think I like this idea of the base times the height giving me the area of a parallelogram. And now let's just go through it. The reason that this is perpendicular, though, and we can go 4 minus minus 20, is because WR is vertical. It's parallel to it's perpendicular to the x-axis. And this is parallel to the y-axis. That's what was given, right? So that's why we're allowed to say that this 16 is a perpendicular height. Then we just apply our distance formula in a sensible way to figure out the vertical distance here. It's minus 4 minus minus 20. It must be the height is 16 units. Well, if you know this nice formula that the area of a parallelogram is base times height, then you just have to put in the numbers. There's your base, 72 over 5. There's your height, 16. Just multiply that together on your calculator, and you'll get 230.4 units. Okay. Now, for some reason, they actually, maybe it is a good thing here. You know, I'm looking at the memo here. Let's just make the memo a little bit bigger. What they did one thing. The perpendicular height is equal to 16, but something that's probably pretty good to say in triangle SRW. That is a good thing to say, SRW. You know, identify the triangle you're talking about. That's something I left out, and that's important. In triangle SRW, the perpendicular height would equal this, and that means it must be 16 units. They didn't say why that's the perpendicular height. I think that might be a good thing to say, but it's good to say in triangle SRW. And then they went the area of all of SRW is just 16 times 72 over 5, because that's the area of the parallelogram, base times height. And there we are. We got the same answer. But I should have said in triangle SRW right there. Yeah, even there in triangle SRW, WR was parallel to the y-axis, and then the rest of what I said. Okay, so That's it. That's how the whole thing works.